OTI Institute, and today we're going to go over Chapter 4 of the AP Calculus AB, okay? So Chapter 4 is called Introduction to Derivatives. So we are being introduced to derivatives finally, okay? So there's three main topics here: limits, derivatives, and integrals. So we have finally reached our second part of our AP Calculus. We are 1/3 of the way through, and we're gonna talk about derivatives. Okay, so before talking about derivatives, I'm gonna talk about the tangent line. Okay, so the tangent line is a pretty easy here. It's just like m here. The tangent line slope equals to limit as delta x approaches 0 of c of f of c plus delta x minus fc over delta x. Okay, so why is the derivative counted as a tangent line? Okay, so derivative, for example, if we're gonna find the derivative of this function, right, it will be this line right here. It'll be a tangent line like that, and this is the derivative. So for example, this is y equals to x squared, and the derivative here will be y equals to 2x. The derivative right here, okay? So it's basically just a tangent line tangent to the graph. So that's nothing that much interesting. We're going to talk about the definition of derivatives. So f prime of x is equal to limit of delta x approaches 0 of f of x plus delta x minus fx over delta x. So the derivative can be expressed in many forms, such as f delta x, dy over dx, d over dx, and y prime. Okay, so these are the forms that the derivatives can be expressed as. So okay, as you can see here, this is notations. Nothing that much interesting here. This is just the application of the definition of the derivatives. So if fx equals to mx plus b, find f prime of x. We just plug the mx plus b in right here, and we get that the derivative of mx will be equal to m. So here I want to talk about something. So for example, let's just say m is 2. Okay, so 2x plus 3. So what is the derivative of fx equals to 2f plus 3? Then what is f prime of x? So here we obviously know from the solution it's actually 2, but how is it proved? Well, you get it from this theorem obviously, but I want to talk about something easier. So if we have like a derivative of like x, okay, so we get nx to the n minus 1. So this is the f prime of x equals to nx to the n minus 1. So you see n here is actually 1. So so if we times 1 here, so n, 2 times 1 is 2. Okay, so it's 2x, but there's no more x because 1 minus 1 is 0, so it's just going to be 2. And the constant, the f prime of the constant is always 0, just remember that. So that's how we get 2 here, 2, and that's basically how we get m. For example, we have fx equals to 2x squared plus 3x plus 1. Okay, what would this be? What would the derivative of this be? It will be if we take nx to the power of n minus 1. So n 2 times 2 is 4. X to the 2 minus 1 is 2 minus 1 plus 3, and then plus 0 because this is a constant. And this will be 4x plus 3. Okay, so this is the derivative of this function. That's how you find the derivatives. Okay, same here. You just plug everything in, and you get negative 1 over x squared. Okay, so in the test, to find this, you don't actually have to do this. You just have to memorize a few derivatives, such as, for example, we have the derivatives of ln x, f prime of x, f prime of ln x. This is actually just equals to 1 over x. Same, and 1 f prime of 1 over x is equal to negative 1 over x squared. And then cosine f prime of cosine x is equal to negative sine x and then f prime of sine x is equal to cosine x. So these are the few functions you need to memorize while taking the AB, so you don't have to go through all these steps again. So next, we're going to talk about a differentiability. Differentiability. Okay, so what this means is if it's what differentiable means, if it's differentiable, then it must be continuous at the derivative of that function must be continuous. So if one function is differentiable, then it must be continuous in its derivative form. Okay, so that's basically what differentiability means. So this is where differentiability fails. Okay, so if a graph has a sharp turn or curve, something like this, something like this is never differentiable, not differentiable, because there's a sharp curve, there's a sharp point here. Okay, so it's never differentiable. So and if the graph has a vertical tangent line like this, or like this, x equals to c, or y equals to c. These actually y equals to c is differentiable here. If it's x equals to c, it's never differentiable as well, because you can't get a derivative of it, or it's gonna be infinite. And if the function is discontinuous, it's obviously gonna be. If the original function is already discontinuous, then it derivative is obviously gonna be discontinuous as well. So it's not differentiable as well. Okay. So here I'll show you 3 terms that you need to know. If a function is differentiable at c, let me get my laser point here. If a function is differentiable at c, then it is continuous at c. Okay, so this does not mean that if a function is continuous at c, then it's differentiable at c. It only means differentiable at c produces continuous at c. Okay, so if a function, the second one here is if a function not continuous at c, then it's not differentiable at c. So if it's not continuous, then it's not differentiable. Doesn't mean if it's not differentiable, it's not continuous. Okay, and finally, if a function is continuous at x equal to c, then it may not be differentiable at x equal to c. Be careful with the may not. Okay, so I'm going to talk about some basic differentiation rules. Okay, so constant rule. F prime of c is always equal to 0 of constant, as I talked about, and then f prime of a x to the n is equal to n x over n minus 1. I talked about this. This is the constant rule. You can take the constant out as always, and then here's the sum and difference. You can just remove the brackets and it still works the same. And this is the sine and cosine. So sine x, derivative of sine x equals cosine x, and then derivative of cosine x equals to negative sine x that I just talked about. Okay, so this question 3 here, it asks us to determine whether the function is differentiable at x equals c. So first we want to solve the we want to know if the right hand limit and the left hand limit is equal. Well, because what it means by differentiable again is when the derivative is continuous. So we find the derivative and find if it's continuous. So one of them lands at 4, the other one also lands at 4. So that means it is differentiable. Okay, so again, the next question here, same thing, show that fx is continuous but it's not differentiable at x equals to 0. Well, I just need to show the definition of the derivative first here, right here, and then we get that it's like f derivative is not continuous, it does not exist, so it's not differentiable at x equals 0. But then we get fx is not differentiable at x equals 0, but gx on the other hand is, because it is an x squared of sine over 1 over x. Okay, so this one here, we can use product rule, which I'll talk about product rule plus chain rule. But later on in the next unit I'll talk about this, but here we can just plug it in as always. It's like basically you have to do thing, just plug it in and find that gx is differentiable at x equals 0. Pretty simple, right? So now I'm going to talk about if determine whether the statement is true or false, okay? So the first one here is the slope of the tangent line is differentiable to the function of f at point 2, and f2 is f plus f of 2 plus delta x minus f2 over delta x. So first thing I notice is that we are missing the limit delta x approaches 0. This is the only thing that's wrong about this. So it's obviously wrong. A. Okay, so for B, if the function is continuous at a point, then it is differentiable at that point. Again, this is wrong because it's differentiable to. If it's differentiable, then it is continuous. Not if it's continuous, then it's differentiable. Okay, so yep. Yeah, that's all for today's class, I guess. But no, I'm just gonna do a quick summary. So in this unit, we talked about a differentiability, the basic definition of limits. Definition of derivatives, and we also talked about derivative rules. Yep, that's all for this class, and thank you guys for listening, and hope to see you in our next class.